Hi everyone, I am Soumojit Chatterjee and this is TLE Eliminators. Welcome to the post-contest discussion of today's Codechef contest. We will discuss the first 4 problems of the contest today. I hope you all had a great contest. So before discussing anything, can someone confirm whether my screen is visible or not? Someone in chats? Okay, great. Let's start then. Okay, so this was the first problem of the contest. It says, the question name is Monster Monster. It says that you have run into an army of n monsters and you must defeat them all. Each monster has a certain amount of health points which you know beforehand. So the ith monster has HI health points. You can attack exactly one monster per day and only if your attack stat A is greater than or equal to the monster's HP. So in other words, you can attack a monster only if you can defeat it in a single hit. At the end of each day, the HP of each alive monster increases by a fixed value x. The question asks, to find the minimum possible value of the attack stat A, you need to be able to kill all the monsters. Note that you are allowed to kill the monsters in any order you like. Okay, fine. So let me explain the problem statement once. Okay, so this is the question says, the input to the problem is an array of integers a1, a2, an, and some integer x. Now, it is said that these values represent the health points of some monster. So these values represent the health points of a monster. And this x is something like their generation power. So basically at every moment, the health power of a monster increases by x amount. So this is given. So basically, suppose I have a monster. Just a second. Yeah. So suppose I have a monster who's at t equal to 0. So at the first day, its health point is AI. Suppose. So as per the question, what should be the health point of this monster at t equal to 1 or the next day? Anyone? Anyone there? Okay. So if at t equal to 0, the health point of some monster is AI, and the question says that at every day, the health point of a monster increases by x. So that means at the next day, the health point of the monster will become AI plus x. Similarly, the next day, the health point will again increase by x. So it will become AI plus 2x and so on. So this is something which the question mentions. Now the question mentions that you have to kill all the opponents and you have some power value which they call the attack stat, which is say A. So basically you can kill. So basically you may kill a monster. So you may kill a monster with say, you may kill a monster with HP equal to P. So suppose you have a monster with health points equal to P. So you can kill him only when your attack stat A is greater than equal to P. So this is what the question mentions. Now what do we need to do? Basically, we are given an array of integers a1 to an, which basically represents the health point of n monsters. We need to reorder them in such a way. So we may jumble this stuff and reorder them in such a way so that it takes the least amount of time. So that it takes the least amount of attack stat to kill all the monsters. Okay. So is the question clear? Anyone, any doubts with the problem? Okay, great. So now, So now suppose this happens. So basically, first of all, tell me, so this is an observation which is very important and crucial for the problem, that suppose you are starting, so suppose you are starting with some attack stat A. Okay, fine. Now, what do you think? What will be optimal? Like, should you, which monster out of all these N monsters you should kill first? Remember that with time, the power of these monsters will increase by X amount. So that means with time, these monsters will become more and more powerful. So now, if I ask you that, okay, at the very beginning, you have to kill one monster, then what do you think? Which killing which monster should be optimal? Any guesses? Exactly. So if you have a bunch of monsters and if you have to kill them, then it is always the most optimal to kill the monster with the largest value. Because if you suppose you kill a monster with a smaller value. So let me write the strategy first. So strategy is kill a monster, kill a monster with largest HP. Now, why is that optimal? That is optimal because suppose you killed a smaller monster first. So you suppose you killed a smaller monster first. So suppose I had two monsters, one with S and one L and other with HPL. Suppose S is less than L. And suppose you somehow killed this monster. The problem is that if you kill a monster with a smaller HP value first, then it may happen that this monster, which was already powerful, becomes more powerful and it exceeds A, and you are not able to kill it. But on the other hand, if you kill the monster with the largest value first, then this value will increase, but it will not exceed. There are less chances that it will exceed the value of A because S is smaller than L. So the optimal strategy would be always to kill the monster with the largest health points first. Is that clear for everyone? Exactly. As the time passes, higher values will increase more, and that is the reason there are higher chances that a higher value may exceed the our health stat A than the lower value. Okay, great. So that means what should be the optimal strategy? So you are given an array A. So you are given an array A, suppose A1, A2, AN, and I know that I should kill larger monster first and then smaller monsters. So it always makes sense that you basically reverse sort the array. So you reverse sort the array. That means if suppose the input array is 3, 5, 1, and 6, you reverse sort this array in this fashion: 6, 5, 3, 1. This basically indicates that we will move in this order, killing all these monsters one by one. So first of all, we will kill the monster with health point 6, then 5, then 3, and then 1 in this fashion. Okay, because it always makes sense to kill a monster with larger health points first and then kill monsters with smaller health points. Okay, fine. So now the question mentioned 2 points. The first one was to reorder the array, and the second one was to find the minimum possible value of health stat. So we have found the ordering. We know that the reverse sorted fashion always works. What remains to find is the minimum value of health stat, right? So suppose let us take that previous example. I've sorted it and it becomes 6, 5, 3, and 1. And suppose the value of x equal to 2. So now I need to kill all the monsters. So suppose at t equal to 0, I come here. So at t equal to 0, I come here. Okay, let me write it like this. So this is the array at t equal to 0. At t equal to 0, I need to kill this monster. So now if I need to kill this monster, what should be my value of a be? My value of a must be greater than equal to 6. Because if my value of a is less than 6, then I am less powerful than this monster, so I will never be able to kill it, right? So at t equal to 0, we kill this monster. And to kill this monster, we need our value of a greater than equal to 6. Fine. Now let's come to t equal to 1. Note that at t equal to 1, this monster has died. So the first monster is of no use. He has died. But all other monsters have become more powerful by the value of x equal to 2. So all other monsters have increased their power by x equal to 2, right? So this is the new array. Every value has increased by a 2. Fine. Now I will try to kill this monster. So I will try to kill this monster. So if I need to kill this monster, then my value of a should be greater than equal to 7, right? Because if the value of a is less than 7, obviously I will not be able to kill this monster. And this thing continues. At t equal to 2, you are again there with a new array, 7 and 5. You will try to kill this guy. And to kill this person, the value of a should be greater than equal to 7 again. And now comes t equal to 3. This monster has died, but this value has increased to say 7 again. And again, to kill this guy, you would require that the value of a is greater than equal to 7. That means after I steps, you come, so you basically move along this array. After I steps, you calculate that what is the power of this monster, and the value of a should be greater than equal to that value. That means, don't you think, like, what basically we need to do? So we are given an array of integers a1 to an, and suppose this is the reverse sorted array. So I've reverse sorted it, and then this is the order, right? Okay, let's keep it zero-based indexing. So let me write this an minus 1 and let me call this a0. Fine. So what do you think when I will reach this ith index? So suppose I reach the ith index ai, what would be the power of this monster, or what would be the health points of this monster when I reach the ith index? Anyone? When I reach the ith index, correct, it should be ai plus I into x, because this value of ai was already there at t equal to 0, and for every I the value got increased by x and x so on, right? So the power when it reaches here should be ai plus I into x. This was exactly very similar to what I wrote in the very beginning. Look how it happens. At t equal to 0, the value is ai. At t equal to 1, the value is ai plus 1 into x. At t equal to 2, the value is ai plus 2 into x. So, when you reach a monster at t equal to I, its power will be ai plus I into x. Now, if you want to kill this monster, so I have to kill this monster now. In order to kill this monster, my value of a should be greater than equal to ai plus I into x. And this should happen for all I. So what is the minimum value of a you can choose such that this happens for all I? The obvious answer is choose the maximum of it, right? So set a equal to maximum of all these possible values ai plus I into x for all I from 0 to 1, for all I from 0 to n minus 1. So basically, if you do that, so you satisfy all the conditions a greater than equal to ai plus ix, and while doing so, you also ensure that the value of a is the least possible. Is that clear? Yeah, exactly, Abhijit. We have to take the maximum of all these values arri plus I into x. So anyone with any doubts? Or please tell if it's clear. Okay, let's see the code once and then probably it should be fine. So the code implements exactly the same thing. I take n as input, x as input, the vector as input, and then I reverse sort this vector, and I finally take answer as maximum of all these values vi plus I into x, and I finally print the answer. As simple as that. So it's clear for everyone, right? Okay, if that is the case, let's move to the next problem. So, fine. So this was the second question. It says crazy jumping frogs. So it says that there are n frogs numbered from 1 to n. there are also 2n buckets arranged in a straight line numbered from 1 to 2n. Let ai denote the index of the bucket containing frog I. You are given the initial values of ai. Every second, the following happens. If all frogs are in the same bucket already, nothing happens. Great. Otherwise, each frog will jump one step towards whichever is the smallest frog that's not in the same bucket as it is. Formally, okay. So it says formally consider some frog I and j with the smallest index as that ai is not equal to aj. And then if aj is less than ai, then frog I will jump to the left. If aj is greater than ai, then frog I will jump one bucket to the right. All these movements are performed simultaneously, and the task is to determine the largest number of frogs in any single bucket at any point of time during this process. Fine. So let me explain the problem statement first. So the question is something like this. So the question says that there are 2n buckets. So let me draw them. So like this, there are 2n buckets. Fine. So you have 1, 2, and this goes till there are 2n buckets. Now there are n frogs as well, and each frog can be in any bucket. So there are n frogs. So suppose the first frog is here, the second, so there are multiple more buckets. So suppose the second frog is here, the third is again here, the fourth one is here, 5 and 6 are here, the 7 one is here, and there can be any random distribution of the frogs, right? Now the question says that the frogs move in a certain fashion. So how does the frogs move? So this is how the frogs move. So suppose you have a bucket. Okay, fine. Now this bucket may have some frogs. So suppose it has a frog 2 and 4. Now basically this frog will look for the smallest frog which is not in this bucket. So what is the smallest frog from 1 to n which is not in this bucket? It is simply 1, right? Okay. So the smallest frog which is not in this bucket is 1, right? So 2 will look for 1. So 2 will look for in which bucket 1 is there. So there are multiple buckets here to the left and right of it, right? So 2 basically looks for in which bucket 1 is there. So suppose 1 is to the right of 2. Then 2 will simply jump to the next bucket to its right. Similarly, if 2 sees that 1 is to the right, to the left of it, then it will jump one bucket to the left. That means at every moment of time, what does a frog do? A frog looks for the smallest frog which is not in his own bucket, and then it jumps in his direction. Fine. So now the question asks for, now this is what the question asks. The question says that suppose this process happens for a long time, then what is the maximum number of frogs in a single bucket? What is the maximum number of frogs in a single bucket? So this is the question asked for. So basically there are 2n buckets. There are n frogs who lie in these 2n buckets, and they all move in a certain weird fashion. The question asks for that what is the maximum number of frogs in a single bucket? So is the question clear? Anyone with any doubts in the question itself? Someone please confirm. Okay. So if it's clear, then now let us discuss what will happen. So suppose there is some frog. Suppose there is some frog which is at some, suppose for example, it is some at index 5. So it was initially at index I equal to 5. Then at the next moment, where can it jump to? it can jump to two possible values, 4 and 6, right? Similarly, now suppose at the next index it is at 4. Then it can jump to two possible values, 3 and 5. And if it is at 6, then it can jump to two possible values, 5 and 7. Right? Basically, why this happens? Because if I have a frog which is in some bucket, then it basically moves to the bucket to the left, immediately to the left of it, or the bucket which is immediately to the right of it. What does that mean? That means that if it is at I equal to 5, which is an odd number, then at the next step, this frog will be at an even number. Similarly, at the next step, this frog will be at an odd number. Fine. So at every timestamp, basically the frog jumps from an odd, changes its parity, right? So that means, so what does that mean? So suppose I have two frogs. Suppose I have two frogs, F1 and F2. Suppose these are the two frogs. And F1 stands, initially F1 stands on some odd index and F2 stands on some even index. My question to you is, can they ever meet? Like, can it ever happen that they are in the same bucket? So can they ever meet? Exactly. So since if I have two frogs which are in different parity of brackets, so that means they can never meet. Why so? Because this one is initially at an odd index, this one is initially at an even index. At the next timestamp, it will go to an even index, where it will go to an odd index. So they will always keep on flipping their parities, and these two frogs always. So this is an invariant. So this is an invariant that F1 and F2, that these two frogs F1 and F2 have to be always at different parities. Fine. So they can never be. So they can never be at the same bucket. Fine. Now here is an interesting observation. So we understood that, okay, if there are two frogs which are in different parity, one in odd and one in an even index, then they can never meet. But what happens when two frogs are in the same parity? So suppose both two frogs are there, both of them are even, or both of them are at odd positions. Then will they ever meet? Like, is it necessary that they will always meet? Anyone? Any guesses? Suppose there are two frogs and both of them are at even positions. So should they always meet, or there are conditions where they may not meet or something? Exactly. If there are two frogs which are at eventually same parity positions, then after some time they have to anyways meet. Let me show you why. So suppose I have these two n buckets. Suppose I have these two n buckets. Fine. So suppose there are these two n buckets, and suppose, for example, the leftmost bucket is at a position of L and the rightmost bucket is at a position of R. Fine. Now think about this. What happens? What happens at any point of time is you look at a frog at the leftmost bucket. This frog will never move to its right, because there are no frogs to the right of it. So it will, whenever it will try to find the smallest index of a frog which is not in the bucket, it will always get in its right direction. So that means all these frogs in this left bucket will surely jump to their right. Similarly, by the same argument, all the frogs which are in this rightmost bucket will always jump to their left. That means at every step, so suppose this was the initial range. So think about this. This was the initial range of frogs. So the frogs were actually between L and R buckets. But at every timestamp, these things keep on shifting and they try coming closer to each other. That means at every timestamp, the value of R minus L, this keeps on decreasing. So that means this keeps on decreasing. So that means this entire range. So that means this entire range keeps on getting smaller and smaller and smaller, right? So that means that at some point of time, they have to somewhere merge and come at the same bucket. So basically, whenever you have two frogs which are at different parities, they will keep on coming towards each other and finally will reach at the same bucket. It has to reach at some point of time. So is the argument clear? Anyone? Okay, great. So we discussed 2 points. So these were the 2 points or important observations which we actually discussed. The first one was that two frogs, two frogs at different parities, at different parity, never meet, never meet. And the second part is that two frogs at same parity always meet. So now can you answer the question? The question asks for what is the maximum number of frogs there can be at one bucket. So suppose I have this integer array given, right? A1 to an, which represents the position of the frogs in the bucket. Now, suppose there are odd number of frogs which are present at odd indices and even number of frogs which are present at even indices. So what will happen? After a long time, all these odd number of frogs will be in the same bucket. So like they will combine in the same bucket. And similarly, all these even number of frogs, they will also be in the same bucket. So what do you think should be the maximum number of frogs in one bucket? Exactly. It should be maximum of odd and even. Fine. So the answer should be maximum of odd and even. Now, if you look at my code, I have actually implemented the exact same thing. So look what I have done. I have taken n as input. I have taken the vector as input. I have counted that, okay, what are the number of odd numbers in the array? So I've counted the number of odd numbers. So if the number of odd numbers is this variable odd, then the number of even numbers in the array is n minus odd, right? Uh, so that means the answer should be simply max of odd and n minus odd. Because after a lot of time, all the frogs at odd indices will be in one bucket and all the frogs in even indices will be another bucket. And so the answer would be maximum of them. Is it clear? Okay, fine. So now, yeah, Vitha, the monster sum is done. So do you have any small doubts on it? Okay, fine. So actually this is recorded, so you can see the solution for it. So we have discussed the first two problems of the contest and two more are yet to go. So I hope that works. Okay. So if you have no doubts, then let's start with problem C of the contest. So it says qUiRkY quests easy. So this is the question. Uh, okay. So it says that suppose you have an array B and consider performing the following operation on it. First, choose any non-empty subsequence of B, then replace each element of this subsequence with the max of B. Note that while you choose a subsequence, the replacement is done with the max of the entire array B, not only the elements of the subsequence. Great. So for example, if B is 10412 and you choose the subsequence 101, those elements will be replaced by the max of B, which equals 3, to obtain 33432. Now the question says that we define f of B to be the maximum possible sum of B that can be obtained by performing the given operation any number of times. So note that since B is changed after a move, its max may also change for future moves. And the question says to compute f of A. So let me explain the question first. Okay. So this is the question. So the question says that you are given an array of integers a1 till an. Fine. Now the question says that you may choose any subsequence of this array. So suppose I choose few integers of this array. And then what do? I compute the max of this entire array. Note that we are not computing the max of these subsequence. In fact, we are computing the max of this entire array, and then we are replacing these AI values with the max. So suppose this is the array A1, A2, A3, A4, A5, A6, for example, and then I choose these two indices A3 and A5, and suppose the max of this array is k. Then basically what we can do is we can replace A3 and A5 with k. So the array becomes A1, A2, k, A4, k, A6. Fine. So now there are few important terms. The first one is what max is. So let me tell you what max of a set of numbers is. So max of a set of numbers is basically, so max stands for minimum excluded. So this is basically the minimum excluded number. So basically, suppose for example, you have this array 3, 5, 0, 2, and 4. Then what is the smallest integer which is not present in this array? It's 1, right? The smallest non-negative integer which is not present in the array, that's 1. So that means the max of this array is 1. Okay. So just asking you for the sake of concreteness, can someone tell me what is the max of this array and max of these, the max, what is the max of these two arrays? Okay, exactly. So if you look at this array, then what is the smallest non-negative integer present in this array? Not present in this array. So 0, 1, 2, and 3, these are all present. So that means the max of this is 4. And similarly, what is the smallest integer not present in this array? So 0 is present, 1 is present, but then 2 is not present. So that means the max of this value is 2. Fine. So now the question says that you do this operation many number of times. How many? It's your wish. How many times do you want to do this operation? But after doing this operation, you need to maximize. So the objective is to maximize the sum of the array. Maximize sum of array. So is that fine? Is the question clear? Ayush and Abhijit, any doubt with the questions? Okay, fine. So if the question is clear, let us try to understand these test cases and see what is the answer. So look at these test cases. So suppose let's look at 1, 2, 3. So this is a good example. So suppose I have 1, 2, 3, 1, 2, and 3, and I need to increase or create the maximum possible sum possible. Okay, fine. So look at the sequence of operations. First, I just choose this element. And what is the max of this array? The max of this array is 0, right? Great. So I choose this element and I replace it with 0. So it becomes 0, 2, 3. Now what is the max of this array? The max of this array is 1 because 1 is not present. So now I choose this and replace this with 1. Fine. So now I get a 0, 1, and a 3. Great. Now what is the max of this array? The max of this array is 2, right? Now I override this 3 with a 2. So basically I now get a 0, 1, and 2. So now you will say that, okay, we had this array 1, 2, 3. Why are you always decreasing these values and you decrease the entire sum to get 0, 1, 2? Because this is where the magic happens. After you have got this array 0, 1, 2, what you can do is, now what is the value of max? The value of max is 3, right? So now you can overwrite all of them with 3s. So the new array becomes 3, 3, and 3. So the sum of this is 9, and that is what is the maximum possible sum possible for this array. So is this clear, like the process by which we got 9? So there was something, so initially we did some operations which initially felt like, okay, that we are decreasing the values, but finally we did something so that the sum increased a lot. So this question actually has a very beautiful pattern in it. Like if you notice it carefully, so suppose I'm given some array. So suppose I've given 0, 1, 3, 10. Okay, let's not take this as 10. So let me have a 1 again here. Okay. So suppose this is my array. Fine. Now, the question is, can anyone guess what is the maximum possible sum I can make out of it? If I have the array 0, 1, 3, 1. Anyone? Any guesses? Exactly. If the array is 0, 1, 3, 1, I can actually make the sum 16. Let's have a look how. First, I know that the max of this array is 2, right? So the max of this array is 2. Then what should I do? Just a second. So I know that the max of this array is 2. So if the max of this array is 2, so note that we will always try to increase the value of max to a large possible value, and then finally overwrite all of the terms with the max to get the maximum possible sum. Like look at here what we did. We initially keep on increasing the value of max. So initially we had max equal to 0, then we got max equal to 1, then we got max equal to 2. Finally, we will have a large possible value of max, and then we will overwrite everything with that value of max to get the maximum possible sum. So that is my strategy. So now initially I have this max value of 2, right? So I initially have this max value of 2. So what do I do? I need to overwrite something so that the max value increases by 1. So I will actually need a 2 somewhere. Now note that there does not make any sense removing the 0. Why? Because if you remove the 0 and make a 2 here, then at the next step, so if you remove the 0 and make a 2 here, so at the next step you will have this array 2, 1, 3, 1. And the max of 2, 1, 3, 1 is 0. So that will be bad. Like you need to try increasing the value of max, not decreasing it. Because once you override the 0 with a 2, then the value of max decreases to 0, and now you can never do anything to get any benefit of the operations, right? So this does not make sense. So even deleting 1 and writing a 2 does not make sense, because if you delete this 1 and write a 2, so what basically happens is, okay, here the problem with 1 is not there. What can you do? You can actually, since there are two ones, you can override this one with a 2. So if you override this one with a 2, so now you get 0, 1, 2, 3. So basically we will try to keep at least one occurrence of every integer from 0 to n minus 1. Once this happens, so now the value of max is 4, because 0, 1, 2, 3, all of these are present. So the value of max is 4 now. So now you can rewrite all of them with 4. So now you get 4, 4, 4, and 4, and the sum of them is 16. So my idea is that I try to override this array with values, so that the max keeps on increasing. Finally, the max reaches some value, and then I overwrite it with all the elements to get the sum. So is the idea clear? Like what are we trying to do? Okay, fine. So let me ask you a question. Suppose I have a bunch of suppose I have a bunch of numbers. So I have this numbers a1, a2, and it goes on till an. Can anyone tell me what is the maximum possible value of max I can have for this bunch of elements? So there are n elements, a total of n elements here. and I'm asking you what is the maximum possible max you can have. What is the maximum possible value of max you can have for a bunch of n numbers? No, Abhijit, it's not n plus 1. If you think about it, then the maximum possible value of max is n. Like think about, suppose n is equal to 1. If n is equal to 1, then what is the maximum possible value of max? You just take this set 0. If you take this set 0, the maximum possible value of max is 1, right? If n equal to 2, you have no choice. Instead of taking this set 0, 1, you have to take this set so that the value of max becomes 2. So that means the maximum possible value of max is the value equal to n, isn't it? Because if you have n numbers, what is the best you can do? If you try to increase the value of max, if you have n numbers, the best you can do is you keep this set. You take everything from 0 to n minus 1. If you do that, then the maximum possible value of max is equal to n. If you ever skip any of these values, then suppose you skip a 2 from the set, then the max will decrease to 2. So if you want to have the maximum possible value of max, you have to keep all these 0 to n minus 1 in the array, and in that case the value of max will be equal to n, right? Yeah, exactly. Since 0 is also there, that is the reason the maximum possible value of max is equal to n. Now, so that means whatever be the array. So suppose you are given an input array. So you are given an input array a1 to an. Don't you think that you can always make some operations? So this has some initial value of max. I don't care what it is. So suppose I have max equal to some value k. But I can always do operations in order to convert this array to this form 0, 1, 2, 3, n minus 1. And at this step, the value of max will be equal to n. And then what will I do? I will simply rewrite everything. I will simply overwrite all of them with this array n, 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 and n. And if that happens, then the sum I can get is equal to n square. Let me show you using an example. So suppose I have this array. So suppose I have a 1, a 3, a 4, and a 3 again. Fine. So now what will I do? Keep on looking the values of max. So initially max is 0. Fine. So if max is 0, what do? Since max is 0, you have to overwrite something with 0, right? So take any element. Take any element and overwrite this with 0. So you get the new array 0, 3, 4, 3. Fine. Now note that at every step, your objective is to increase the value of max. So now the value of max has become equal to 1. So now what do? You take the next element. You take the next element and overwrite it with 1, the value of max. So now it becomes 0, 1, 4, 3. So now the value of max is 2 now. Fine. So now you again take this element and overwrite it with 2. Okay. So if that happens, then the value of then the array becomes 0, 1, 2, 3, and the max has now become 4. That means if you keep on continue doing these operations, if you keep on increasing the value of max at every operation, there will come a time when the value of max will be equal to n. So here the value of n is 4. So the max have become equal to 4. And once this happens, now this is the opportunity for you to overwrite everything with force to get the maximum possible sum, which is equal to n square. Is that clear? Like how can we achieve a sum of n square? Okay, Abhijit asks a very nice question. So can we say that answer is maximum of curve sum or n square? So we will have a look at it, Abhijit. But like, is it clear that, okay, we can achieve n square somehow? So the answer is never less than equal to n square, right? So the answer is never less than n square. Either it is n square or it is something larger than that. Agreed? Okay, great. Now, so suppose you all made a guess that, okay, so as you said that you say that, okay, what we will do, we will return this as our answer. So suppose you say that my answer is maximum of current sum. And then you have this n square. So we all claim that this is my maximum answer. What actually is that this is wrong. This does not work. The idea is very similar to what I have discussed, but then there is a catch to it. Let me tell you what. Basically, consider this test case. Okay, let me think a bit. So let me make a test case for which this may fail. So let me have a 1, a 0, a 1, and a 10, for example. Fine. So if we use this algorithm, then what is the maximum? Then what will be the answer you will return? Anyone? For the array 1, 0, 1, and 10? Guys, the simple algorithm which Abhijit suggested that you take. Is it 25? We have just 4 integers. So let me write it down. So we have 4 integers, 1, 0, 1, and 10. So the value of current sum, as it seems, is 12, and the value of n square seems to be 16. So if you just return this and you print this as the answer, you should print 16, right? Yeah, fine. It should be 16. But let me show you a process where you can actually get a sum of more than 16. So let me show you this. So I had this 1, 0, 1, and then I had 10. Fine. Now, what is the max of this? The max of this is 2, right? Great. The max of this is 2. And our objective would be always to keep on increasing the max value. Very good. So now I have 1, 0, and suppose I override this with 1 with a 2. So now I have a 2 and now I have a 10. Very good. Now the value of max has increased. The value of max has become equal to 3. Now there are two things you can do. There is one way which is actually bad. So there is one way which is actually bad. That is simply overwriting this 3 with the 10. So you get a 1, 0, 2, and a 3. And then you have this value of max equal to 4. And then you simply make all 4s. So this gives the answer 16, as we already discussed. So this is which we have already discussed. This gives a value of 16. But then there is an alternative way. That is, why don't we stop here? I see that 10 is a very large value. 10 is a very large value. It does not make sense to override this. Why not just stop here and overwrite all these with this 3 which I have in hand? So overwrite them with 3. If that happens, then I get a 3, 3, 3, and a 10. And I stop here. Then what is the maximum answer I can get? From here, I can get 19, which is better than the 16 which we already had. Isn't it? Is it clear why does this test case fails for our solution? Exactly. So that means just printing the maximum of the current sum and n square would not work, because there are cases where you may take a smaller prefix and you can actually increase the values. So that means, what does this operation gives you a power of? So suppose you have this array of integers a1, a2 times, and it goes till an. Then it is not necessary that you overwrite everything with n. That is not necessary. What you can instead do is, you take the first k values. You take the first k values. You can override them with k. So all the first 4 values, k values become k. And the rest of the remaining values come as it is. Fine. So the rest of the remaining values come as it is. So that is a possible operation. Look exactly what we had done here. So basically what I'm saying is, if you have 1, 0, 1, and 10, So you can obviously convert this entire array into an array of 4s. That's a possible configuration. But you can also do this. You take the first 3 elements and then you convert them to 333 basically and keep the remaining as 10. So that is also a possible solution which you can actually simulate through our operations, right? Is that clear? Okay, great. So that means so that means what should we do? So now suppose I have asked you that, okay, there is some a large array A1 to AN, and I will choose some k values out of them. I will choose some k values out of them and I will try to override them with k. So what do you think? Which k value should I choose? Out of these n choices which I have, which k value should I choose? Any guesses? Like there are some n values, I have to choose k out of them. Exactly. So since I need to make the sum maximum, it always makes sense that I choose the smallest k values and override them with k and keep the largest values as it is, because that will lead to the maximum sum, right? So that means the idea is simple. The idea is simple that you first sort. You first sort the entire array. You sort the entire array. And now you run a loop for k equal to say 1 till n. And now in this loop, you basically, so you have sorted this entire array. So you have this sorted array A1 to AN. So in this loop, what will you do? You will basically take these first k values, right? And then you know the sum from here is k square. And you can find the sum of the remaining part using prefix sums, or there are other techniques as well. So you compute this sum. And then you take the maximum of this value for all k. That should give a valid answer, right? Exactly. We can do this for every possible value of k from 0 to n, and then we can actually finally compute the answer. So let me show you the code once. The code follows this exact same idea. So look what I have done. I have taken n as input. I have taken the vector as input. I have computed the sum, and then I've kept answer as sum. Here what I've done is I've reverse sorted the array. So basically, instead of doing prefix sums and other thing, I have reverse sorted the array. So I start from here. When I start from here, I already know the sum of this, right? And then I can simply take the remaining elements and square them up. So so that is basically the same thing, just I'm doing it from the reverse. So look what I've done. I've reverse sorted the array. I have computed the value of sum. So sum is the sum of elements which I've taken till now. So I take the sum up to this, and for the remaining part, I take the square of them. Okay, so this way I've computed the answer. I have also taken maximum of answer with n square, because I know n square is a possible answer which I can always get, and then I've printed the answer. So that works. Is it clear? Abhijit, is that clear? Okay, great. So if that is fine, we can move to the next problem and the last problem we will discuss today. So this was the question. So the question says that you are given an n cross m grid A, and let I comma j denote the square in the ith row from the top, jth column from the left. So each square is either empty or blocked, but 1 comma 1 and n comma m are both empty. Fine. So now two robots are placed initially together at 1 comma 1. Great. At every second, both the robots must move to an adjacent empty square. Okay. And it is said that the robots choose their movements independently of each other. And there is only one restriction. At any point of time, both robots must not be on the same square. Fine. And the question says that the goal is to find the minimum time needed for both the robots to be at n comma m simultaneously, or determine if this is not possible under the given constraints. Okay, so let me explain the question once. So this is what the question says. It says that you have a grid. So this is a grid. They are which they actually denote with dots and hashes. So there is some grid like this. There are n rows in the grid. So it is a grid of size n cross m. And a dot represents an empty cell. So dot means an empty cell. Hash means a blocked cell. Okay. Now the question says that there are two robots, both initially, so there are two robots R1 and R2, both initially stand at 0, 0. Fine. Now they need to move in a certain fashion and in the minimum distance reach this final node. So suppose this is n minus 1, m minus 1. In the minimum time possible, they need to, both these robots need to reach n minus 1, m minus 1. It is said that any robot R can move in any of the four directions. Fine. But it can only move to a dot. It can never move to a hash because these hash cells are by definition blocked. So it can never move to a hash cell. Fine. There is one very important constraint which the question mentions is that apart from these two cells 1, 1 and n, m, R1 and R2 can never stand at a cell at the same time. So it may not happen that, so suppose R1 is choosing some path like this, R2 is choosing some path like this. So it cannot happen that R1 and R2 choose a path such that they at the same time they are both at the same cell. So they have to be always at different cells or at the board at the same time. So that is the constraint. And using this, we have to find the minimum time it takes for both the robot to reach from 0, 0 to n minus 1, m minus 1. Fine. Is the question clear? So, okay. So are you properly able to understand the question? We will discuss it here only. So probably it would not be a issue if you have not seen this question. So okay, fine. So since the question is clear, let me try to explain what happens. So we will look at cases one by one. This was actually not something which involved DP here, but was more of a graph traversal like question. Okay. So suppose suppose 0, 0 is a dot. It is given that 0, 0 will be definitely a dot. And suppose this cell 0, 1 is a hash. And suppose this is again a dot. Okay. And now you have this large grid, and there are all these cells filled with dots and hashes. Okay. Fine. And the final cell n minus 1, m minus 1, which is also a dot, this is where you have to reach. Great. So now you had two robots standing here, R1 and R2. And we need to find paths such that R1 and R2 both have to always be a disjoint cell. So they can never stand at the same cell, right? And it is necessary that both R1 and R2 always move. So they can never stand still on some. They have to always move at some direction. Fine. So what do you think the answer for this is? Is it ever possible for both robots R1 and R2 to move from 0, 0 to n minus 1, m minus 1 without actually standing at the same cell? Is it possible? Look at the choices what R1 and R2 does. Like at the next time moment, R1 has to definitely come here. No other choice, right? Because this cell is blocked. Similarly, R2 also has to definitely come here. So that means at t equal to 1, both of them will be standing here. But if both of them stand here at t equal to 1, okay. Yeah, so if both of them stand at t equal to 1, so that invalidates or violates the condition that both the robots cannot stand at the same cell, right? So the answer for this is simply no. So the answer for this is simply no. The exact same case happens when at this position you have a dot and you have a hash here. then also both these robots have to move at this position at t equal to 1. And in that case also the answer is no. So is that clear? Okay, great. Now the same condition happens can be applied here. Look at this part. Like you try to reverse the entire paths. So suppose you have a hash here, and then you have a dot here. So now, so you have a dot here. So now it is said that both the robots have to reach here at the same time. So some robot has to come from here, some robot has to come from here, right? Both can't come from this direction. So that means if at least one of them is blocked, then also the answer is a no, right? That means, what does that mean? That means you can make an initial check. So make an initial check that, okay, if grid, say grid 0, 1 or grid 1, 0 or grid n minus 2, m minus 1 or grid n minus 1, m minus 2, if any of them is blocked, if even one of them is blocked, then the answer is simply no. So if any of these are blocked, the answer is simply no. So that is for obvious reasons, like because otherwise we will never get a path such that this happens. Fine. So now what remains is, okay, what remains is, so I know, so I have some grid. So this is a dot. We have already argued that both of these positions have to be dot, otherwise it's not possible. And now there is a dot again here. This is, and again we have these left and the top positions to be dot. So this is my 0, 0, and this is my n minus 1, m minus 1. Fine. Now if I ask you that what is the shortest distance from here to here, from 0, 0 to n minus 1, m minus 1, like forget two robots, everything, forget that they cannot stand at the same cell, and just try to find the shortest distance from 0, 0 to n minus 1, m minus 1. So so how can I do that? No, it is not necessary to be n plus m, right? Like, because what can happen is, so suppose there are lot of hashes here. So suppose there are a lot of hashes here, and due to these hashes, they actually force a very long path. So suppose they force a path like this because there are hashes, right? So it is not, if the entire grid was empty, then you simply take this and the number of the distance would come something like n plus m. But if there are hashes involved, then actually the number of the shortest distance between 0, 0 to n minus 1, m minus 1, that is not necessarily n plus m. But then there is some very famous algorithm which you can use for this part. If you know about graph traversals, the very standard algorithm which we use to find shortest distance in grids or graphs is a BFS. So we will use a BFS, so a breadth first search, to compute the distance from 0, 0 to n minus 1, m minus 1, right? So that will help us to find the distance from 0, 0 to n minus 1, m minus 1, or to all other nodes for per se, using a BFS. Great. So that works, Abhijit? Okay, fine. So now we can basically, so suppose the shortest distance from 0, so you did a BFS and you found out that, okay, the shortest distance from 0, 0 to n minus 1, m minus 1, that is D. Okay. So now my initial argument is, so suppose this is the case. So you have this 0, 0, and then there are two empty cells here and here. And then you have n minus 1, m minus 1. And then there are two empty cells here and here. And suppose this is the shortest, suppose there is some shortest distance. I don't know, but there is probably some shortest distance you can follow and finally reach here. Fine. Now, don't you think like robot 1 and robot 2 can do something like this? Like let robot 1 follow this same path. Okay. So robot 1 follows this same path. Fine. and let robot 2. So if robot 1 goes here at t equal to 1, robot 2 must go here at t equal to 1 because they can't be in the same node. So robot 2 goes here, but later at the next timestamp, let it come back here, and then let it again move in the same direction. So basically, what I'm saying is that at t equal to 0, both robot 1 and robot 2 are here. At t equal to 1, let robot 1 come here and robot 2 go there. At t equal to 2, let robot 1 jump back here, so it reaches here, and let robot 2 again come here. And now what does robot 2 does? It just, oh, so now let me redraw this once. So now what does happen? So now robot 2 has already come here. So now robot 2 simply follows this path which robot 1 has followed. Right. So robot 1 was already ahead of him. So robot 1 reaches here and robot 2 simply follows him. Finally, so that means since the shortest distance is d, that means in d plus 2 time, we can always, both the robots can always reach n comma m, right? Because robot 1 simply follows the shortest distance. Robot 2 takes 2 extra seconds to jump this, and then it again follows the same path, right? So in d plus 2 seconds, it is always possible to basically reach from 0 comma 0 to n plus m. Is that clear? Like why d plus 2? So what I'm arguing is, okay, so I have not argued about d plus 1 yet. What I've argued is that the answer will not never exceed d plus 2. The answer can be d plus 1, can be d plus 2, but it will never exceed d plus 2 because I have already shown a way how you can do it in d plus 2 time, right? So now let me come back to your question, why not d plus 1? Basically, whenever you have grids are a very special class of graphs. So if you look at grids, grids are a very special class of graphs and they are called bipartite graphs. Basically, you can always think grids as chessboards. So suppose you have some grid like this. So it is always a good way to think grids as chessboards. So you think that, okay, so these are suppose my black cells. So all alternating cells are black and the remaining cells are white. Fine. So now, if there is any path from 0 comma 0 to n comma m, and suppose the shortest distance is d, fine. So if the shortest distance is d, so suppose this is my my shortest path looks something like this. It goes to x1, it goes to x2, and it finally reaches xd. Fine. Look at the color of these nodes. So it was initially white, it was black, it was white, and it goes on, and suppose this is white or black, does not matter. But note that if you ever try to find the path of d plus size d plus 1, so suppose I try to find a newer path of size d plus 1. Okay, let's see what the problem we face. So suppose there is a new path of size d plus 1, p1, p2, and this goes till pd, and then pd plus 1. So now look at the colors. So it also started at white. Now in a grid, if you ever start at a white cell, you have to always go to some black cell, right? So the next color should be black, then it should be white, then it should be black, then this should be white, and then this should be black. But look at this. This is 0 comma 0, this is 0 comma 0. Both of them were white. You said that I had two paths, one of size d and one of size d plus 1 in the from 0 comma 0 to n comma m. That means you are saying that this is n comma m, n minus 1, m minus 1, and this is also n minus 1, m minus 1. But then they are of two different colors. So that is a contradiction. Basically, this is a property of grids, which I think you can remember, and this is very intuitive. You can never have you can never have shortest paths of different parities in a grid. Like suppose you have a shortest path, or suppose you have a path of between two nodes in a grid whose and the path length is 10. Then the only path lengths which are possible is 12, 14, 16 and something like that. For example, take these two nodes. Suppose let me take for example this node and this node. Fine. So what is the shortest distance to it? So the shortest distance to it is 2, right? Okay. Now consider any other path. So let me take this path. So, okay, so what is the length of this path? It's 1, 2, 3, 4, 5, and 6. So it is 6. So in a grid, suppose all the paths or all the distances are of the same parity. So if the shortest distance is even, then all other distances also needs to be even. So that is the reason why if my shortest path is D, I know the answer. So I have already shown you that, okay, D plus 2 is a possible answer. So D plus 2 is possible. And since grids are bipartites, and because of the condition that we can color grids in such a fashion and we can get a contradiction, I have already shown that D plus 1 is not possible. Fine. So is the argument clear why D plus 1 is not possible? Does that make sense? Okay, great. So that means suppose you are given the grid. You first make some initial checks that okay, the positions at 0, 1 and 1, 0, they should be dot. Similarly, n minus 2, m minus 1, they should be dot. Okay. Now you do a BFS algorithm to find the shortest path from 0, 0 to n minus 1, m minus 1, and suppose you compute it as D. Okay, so that is D. Then what I have already discussed is, then the answer is either D or D plus 2. It can't be anything else, right? Either it is D plus 2 or it is D. It cannot be D plus 1. It cannot be D plus 1 because grids do not allow that. And it will not be something larger than D plus 2 because I've already shown that D plus 2 is a possible answer and we need to output the minimum time required. So it is D or D plus 2. Fine. So now, how to check whether the answer is D or D plus 2? That remains. So how to check if answer is D or not? If the answer is D, if we can check answer is D, and if it says, okay, yes, answer is D, then we are done. And if the answer is not D, then we will print D plus 2. That's fine. So how to check if the answer is D or not? Note that if you need to check that the answer is D or not, so suppose this is your initial point, 0, 0, and you have this final point, n minus 1, m minus 1. And if the answer is D, that means basically you have two vertex disjoint shortest paths. Right? Two paths which do not touch at any position and both of their distance is D, isn't it? Right? Do you agree? Exactly. So the answer is either D or D plus 2 based on obstacles. Okay, Abhijit, actually doing BFS and storing the paths usually is not a good idea, because even if the shortest path is D, what usually happens is that there are many paths. Like in a graph, suppose the shortest distance is D, but then there can be many paths from here to here. So how many paths will you store? So it is usually difficult in BFS to enumerate the number of possible paths. Like usually it cannot be done. So you have to find something else. Okay. But this is clear that if the answer is D, then there should exist two different paths. How will we check it? That is possibly not that easy using BFS. But then it is at least clear that, okay, there must exist two disjoint paths, right? Do you agree with this? Okay, great. So now what will I do? So how can I check that, okay, does two different paths exist or not? First of all, let's do one thing. So I have two nodes. I have this 0, 0. So I have these two nodes. I have 0, 0, and then I have this n minus 1, m minus 1. Fine. So first of all, let me do So let me take this node U. Then how can I check that does there exist a shortest path which passes through U? So does there exist a shortest path from 0, 0 to n minus 1, m minus 1 of length d which passes through U? I want to check that. How can I do it? Any idea? So suppose I have been given some node U, and I ask you that, okay, does there exist a shortest path from 0, 0 to n minus 1, m minus 1 which passes through U? So usually the pretty handy way to check this is you first do a BFS from 0, 0. So you know this distance. Suppose this distance is d1 and suppose this distance is d2. So if d1 plus d2 is equal to d, then that means okay. So if d1 plus d2 is equal to d, so that means okay. So u is basically a node which lies on some shortest path. Fine. So this way you can find all those nodes u, v, w such that there exists some shortest path of length d in the grid between 0, 0 to n minus 1, m minus 1. Fine. Now the easiest way to check whether there are two disjoint paths or not is to basically check that, okay. So basically if there exist two disjoint paths from 0, 0 to n minus 1, m minus 1, then for every distance x. So basically suppose, let me draw it on a new page. Suppose I have this 0, 0 and I have this n minus 1, m minus 1. And suppose I have two different paths, which are both the shortest paths, right? So my idea is very simple. So that if this happens, that means for every distance x. So for every distance x, so if suppose this distance is x and this distance is x, for every distance x, there must exist at least two nodes which are at a distance of x from 0, 0. Right? Do you agree? Great. So that means what can we do is we simply iterate over x. So we iterate over x from 0 to d and then check that for every x, okay, there must exist at least two nodes which are at a distance of x from u, isn't it? Like if there exist two nodes which are at a distance of x from u, and we need to consider only those nodes which lie on a shortest path. Note that there can also exist some nodes. Suppose there is some one more node, say w, which is also at a distance of x, but then w does not lie on a shortest path. So that means for w, this d1 plus d2 equal to d condition is not satisfied. Then you do not consider this. You do not consider the w node. Okay. So out of all those nodes which lie on a shortest path, just check that, okay, does there exist multiple nodes at a distance of x? If this happens for all x, then I know that, okay, answer is D. If there exists an x for which there is only one node, that means both if there exists a x such that there is only one node which is at a distance of x from 0, 0, so that means both the shortest paths has to somehow merge at that point, and then you can never have vertex disjoint paths, isn't it? So is the idea clear? Okay, great. So the idea is simple, that we know that the answer is either D or D plus 2. And if the answer is D, then there must exist at least two disjoint paths from 0, 0 to n minus 1, m minus 1. How to check whether there exist two disjoint paths from 0, 0 to n minus 1, m minus 1 or not? Basically, simply iterate over all values of x, and for all values of x, check whether there exist at least two nodes which are at a distance of x from 0, 0. So that is what I have done. Let me show you the code. So here is the code. Okay, fine. So I've actually used the testers code here because I found the implementation a bit cleaner. So let me show you what they have done. So basically they have taken n and m as input. This takes input the basically grid. So it takes the grid as input. That's fine. Now they have done one base indexing. So if you see that, okay, if A12 or A21 is hash or if you see that, okay, a n minus 1 m or a n m minus 1 are hash, then we have already discussed that the answer is -1. Pretty fine, right? Now we compute the two arrays, dis1 and dis2. So these are simple BFS codes. Dis1 computes the distance of all nodes from 1, 1, and dis2 computes the node of all nodes of distance of all nodes from n, m. Fine. Now, here I store in the value of SP the distance of n, m from 0, 0 from 1, 1 in one based indexing. And if I see that SP is -1, that means it is just not reachable. So if it is just not reachable, you return -1 and return. Fine. So that is clear. Now, here you count, like this is the CNT array, and this basically counts at how many nodes are there at a distance of D. So basically I do a CNT D++. So I basically count how many nodes are there at a distance of D from 0, 0, right? And I take only those nodes for which dis1 I, j plus dis2 I, j equal to SP. So that is what I have discussed. I consider only those nodes which lie on some shortest path. Because if there is some node which does not lie on any shortest path, then there is no point actually having it in count array, right? So I do that simply. Now I initialize the value of answer with SP, and for every value of I check that, okay, is count of I equal to 1? If the value of count of I equal to 1, that means that there is no that means that there are no disjoint paths, because any two paths must pass through this node. So if there are no disjoint paths, I set answer as SP plus 2, because now I will print D plus 2, and then I break. And if this not happens, then answer equal to SP plus 2 is never set. So answer remains SP, or basically the value of D, and we print the answer. So is that clear? Abhijit, any doubts?
सर बेसिकली मतलब सोर्स नोड x मान रहे हैं फॉर एवरी x वो आई एम ट्राइंग टू गो टू 0 0 and nm.
या मतलब बेसिकली फॉर एवरी डिस्टेंस x हम देखना चाहते हैं, तुम जीरो यू स्टार्ट फ्रॉम 0, 0, and then for every distance x you check that, okay, does there exist at least two nodes which are at a distance of x? Because if there exist two disjoint paths from 0, 0 to n minus 1, m minus 1, then there must exist at least two nodes na, which are at a distance of x from 0, 0. So try making a count array. So basically the idea is try making a count array. So what does count one store? Count one store that how many nodes are there which are at a distance of 1. So how many nodes are there which are at a distance of 1 from 0, 0? Count two stores. How many nodes are there which are at a distance of 2 from 0, 0? Okay. So if you ever find some count y, suppose you say count y is equal to 1. What does that mean? That means at a distance of y, there is only one node. So what does that mean? That means that if you start from 0, 0, if you start from 0, 0, and then you go a distance of y, if you go a distance of y, then there is only one node. There are no two disjoint nodes. So there is only one node. Okay. So the shortest path may be something very different here. But then, and you reach n comma n minus 1 comma m minus 1. But then there is this distance y such that there is exactly one node which is at a distance of y from 0, 0. So that means all paths from 0, 0 to n minus 1, m minus 1, that must pass through this node. So that would create a problem. So that means two disjoint paths are never possible. So in that case, we print D plus 2. Otherwise, we print D. Okay, so is that clear?
सर मतलब फाइनली यही मतलब है कि हाँ कि अगर मतलब वन नोड्स पे कितने वन के डिस्टेंस पे कितने नोड्स हैं, टू के डिस्टेंस पे कितने हैं, तो अगर कोई भी ऐसा नोड मिल जाता है जिसके लिए मतलब एटलीस्ट टू के डिस्टेंस पे नोड्स मिल जाता है, मतलब दो नोड्स ऐसे मिल जाते हैं, तो मतलब आंसर पॉसिबल है डी. ये ना
करेक्ट करेक्ट करेक्ट. अगर हर डिस्टेंस के लिए एटलीस्ट दो नोड्स मिल जाए तो फिर आंसर पॉसिबल है, एल्स इट्स नॉट पॉसिबल.
हर डिस्टेंस के लिए कि मतलब किसी भी एक डिस्टेंस के लिए.
नो, सी, look at paths like this. Look at paths like this. So you have this 0, 0. You have this n minus 1, m minus 1. Now look at paths like this. So you have a path like this. So here there exist distances जहाँ तो यहाँ पर ऐसे डिस्टेंस एग्जिस्ट करते हैं जहाँ पर तुम्हें दो अलग अलग नोड्स मिल जाए, राइट?
Yes, sir.
But still the paths are not disjoint. Why? Because this condition of having two disjoint nodes must hold for every distance. Even if there
हाँ,
exists one distance जिसके लिए ये condition hold ना करे, you will not get a disjoint path.
yes, yes, yes,
Fine.
yes, sir.
Okay, great then. That is what I had. Let me close
मतलब
the recording.
इम्प्लीमेंटेशन खुद से करके देखना पड़ेगा तभी ज्यादा अच्छे से क्लियर होगा।
Exactly.
हम्म।